Welcome to tutorial 6 on using the OCC Weather Centre as part of our Weather Centre tutorials. The OCC Weather Centre can be a professional meteorological tool for both analysis and forecasting. So far in this tutorial series, we've outlined all the analysis tools, or most of the analysis tools. There's a couple of advanced tools we'll talk about later on in the tutorial series. However, this time I want to look at the forecasting tools we offer, and in particular, computer model data. Firstly, I'd like to say that this is not going to outline the pros and cons of different types of models. That could take an hour or two to go through all that. What I would like to tell you though is that we do have a PDF document. Download the Oz Cyclone Chasers Weather Centre forecasting booklet, and that talks about the different ins and outs that we use different models for, why we use them, what their limitations are when we don't use them, and what we look for in the model data for different types of weather systems, and in particular for thunderstorms and severe thunderstorms at that and or tropical cyclones. So that's all we cover in the PDF document. We shall not be covering that in the tutorial, otherwise it will go far too long. We have a comprehensive suite of models available to our subscribers, and in particular some exclusive models as well that aren't available to the general public. Once again, when you first access the Weather Centre, you'll be faced with a blank map of Australia. Once again, this is from tutorial 1. What I like to use is the locations overlay, the boundaries overlay, and if I'm looking at rainfall data, the catchments overlay, but we'll leave it as locations and boundaries for now. To access computer model data though, you need to click on this overlay here called Models Overlay. So if we click that there, we will see the last model that I was using. Your Weather Centre remembers what you were last looking at. Alrighty, so let's use a global model. Now from the models menu, you'll find Models Control. So here, as soon as I click, let me just do that again for you. So as soon as I click Models, what you'll find right at the bottom of your image, down here where my cursor is a new little submenu that will pop up. Have a look. Models, there it is there, Models Control. Click to expand. So let's click that and expand that, and it shows you what model I'm looking at, when the model was run. Just as a heads up, this is what the timeframes are. So 06Z is 4 p.m. Queensland time, 12Z is 10 p.m. Queensland time, 18Z is 4 a.m. Queensland time, and 00Z is 10 a.m. Queensland time. So these are done in Greenwich Mean Time, or Zulu time, which is the global standard, and you need to then interpret them in our time, in your local time. And in this table, it tells you what time the various models are updated. So you can see at, for example, the GFS model, the 00Z run, so the 10 a.m. run in Queensland time, is updated at 3 p.m. Queensland time. And the reason it's updated so much later than the actual time that the model is run is because it takes so much time and computing power at the GFS central servers to run all of the data to create the model. Okay, so to create the output of the model, I should say. And so that happens both the GFS, the Access, the UKMet, the CMC, the OCF, the ECMWF. All these computer models take a long time to be able to process all of the data that they're given. And so that's why they're updated on the actual user interface on the Weather Centre at these times, even though they were run at, for example, 10 a.m. or 10 p.m. But they're not updated for a few hours after that point. If we take a look at the models overlay, we can see here that we have various basic models. So these are current observations. So this isn't really a model, this is just a bunch of observations that have been taken over the last half an hour, and they've been put into a graphical format. So we can pick the current observations and have a look at when the latest of that was run, which is at about 2:11 p.m, which it's now 2:17. So this was run 6 minutes ago, and we're looking at the nationwide temperature. So you can see that it's pretty warm up north, it's pretty cool down south. Here is where we've got the model types, or the parameters, and so you can see here we've got the temperature, the dew point, the rainfall since 9 o'clock, wind speed in kilometres an hour, wind gusts in kilometers an hour, wind speed in knots, wind gusts in knots. Now, this is a really basic model, okay? So this isn't really one that we use for forecasting, but it is one that shows us it's a good analysis tool. Now, the first of the forecast models is the OCF. The OCF is in itself a very basic computer model that combines a number of different other computer models all to create an output for us. And in this model, this is just the basics. If you're just interested in the basics, will it rain, won't it rain? Well, here's a good model for you to use. Of course, it's a pretty limiting model. It doesn't really delve too deeply into what's going on. So this is a maximum temperature you can expect, and you can choose your slider to move the time. So you can see Wednesday's maximum, Thursday's maximum, Friday's maximum, and so on and so forth. Minimum temperatures can follow the same thing. 24-hour rainfalls, you can see here how much rain we're expecting over any 24-hour period when we combine all the models together. As I say, very basic tool. Doesn't tell you the intensity of that rain, doesn't tell you whether it's coming from storms or not. So it's one of those tools that we just use for a really quick snapshot. If we just want to know, is it going to rain tomorrow? This is a really nice little model to show that, yeah, it might, no, it won't. And then as we progress through, you can see the probability of that rainfall, and you can see there's almost 100% chance of rain across southern Queensland, for example, on Friday in this model. So, as I say, real basic level parameters here for the OCF, and that's why it's under the basic models submenu. Now, these are local models, so what will happen here is if I click Access See North Queensland, what will happen is that in the Australian image, you'll note that the model only pops up in a portion of Australia that the model covers. So for example, in Access See North Queensland, it's a regional model. It's a very high resolution model, but it only covers a portion of Australia here in North Queensland. So for example, if I'm looking at Western Australia and I try and access this model, what you're going to get is once it does load itself, you're going to find that the entire screen will be black and it'll say this entire grid undefined. So you need to be in the part of Australia where that model covers. And for these local models, there's certain areas where they cover. For example, the Southeast Queensland model covers, you guessed it, Southeastern Queensland and the area around it. So that includes Central Queensland, includes the southern inland parts of the state. Access See Northern Territory, well, that covers the top end, for example. WA, well, that covers the Perth area and the area around Perth within 500 or so kilometres of it. So you need to understand what model you're using and what part of Australia are you looking at. Otherwise, you're going to find you're going to have a black screen and then you're going to be cranky and not know what's going on. So make sure that you understand that the local models will only work if you've selected the local area that they're in. Just one other quirk with the local computer models is that because they are such a high resolution model, it does take a little bit of time for the system to catch up with what you're asking it to do. So if you are looking at a loop, so if you're trying to loop this, just be aware that it might take a couple of goes before the loop is fully loaded. So there'll be a lot of patchiness in the loop, and there'll be a lot of weird and juxtapositioning of different time steps until the model is fully loaded. This really is a big quirk of only the local modeling. The local modeling is really notorious for this, and the only reason it happens is because there's so much computing power that goes into dissecting all of the data that comes out of the local model, because it is such a high resolution model compared to all the others like the GFS or the EC or all these normal ones that you're used to. The local models certainly are much, about 5 to 6 times the resolution of those global models. So it does take a little bit more time and a bit of patience when you're using those models. So if we do take a look in the global model range, we have the UK Met Office. So all these will operate through Australia and Australian waters. So I don't have to be so mindful of what location I'm looking at. So if you take a look at the Australian overlay here, you can see the UK Met model operates throughout the Australian region. So too does the GFS, so too does the Access G, so too does the CMC, the European model, and those are our global models. Once again, these are a good starting point, and then once you've localized an area that you want to hone in on, I'd be choosing that from the drop-down menu and looking at that area in more detail. Because global models aren't as highly resolved as the local models, I'd only be using global models in a national, state, or regional overview. So for example, if I want to look at Cairns in this example, and I want to look at the model data, I probably don't want to look too much higher resolution than about 128 kilometers. So that's about as local as I'd want to look at a global model. If I'm looking at the Access C model for North Queensland, I'd be going right into the 32, 64 kilometer levels, because I want to know the nitty gritty of what's going on in my local area. So that's the way I would use global models. Global models, you look at a regional or state or national overview and then hone in on that in using the local models. You can see various parameters on the different models. So you can see here in the drop-down list where it says model type, we can see all the different parameters we have. So we have rainfall parameters, we have wind parameters, all various types of winds at different levels of the atmosphere. We have specific storm parameters, and once again, I'm not going to go into what they all mean. We have a booklet for that goes into detail about what they mean and what we're looking for. And then we have miscellaneous parameters and cyclone charts, so specific charts that deal with tropical cyclones and forecasting tropical cyclones. So we have all these different parameters and lists on the drop-down list here for model types. So please check them out. It's going to take you a little bit of time to get used to using computer models. They're not a simple weather app. It is much more complex, but it's also much more powerful than a simple weather app. And I have certain favorite models that I use and certain models that I don't particularly like to use. And once again, I can go through those in the PDF document. So please check that PDF document out if you're interested in which models I tend to use most and which models tend to be more accurate for which scenarios. And I've also got some helpful tips on the OCC Weather Centre tutorials page about which models I use for what scenarios as well. Lastly, here over the model slider, some models only go out to a few days, some models go out to as long as 2 weeks ahead. So just be aware of that in terms of the model slider. They're not all going to get to the same endpoint because they don't all go out as far. They're not all run out as far. For example, the UKMET model in this scenario is only run out to 6 days. Some of the other models are run out to 14 days. The Euro model is run out to 10 days. So it just depends on which model that you're using. The local models, because once again, they're using such a really high resolution amount of data, they can only go out 36 hours. So they can only be used for very localized areas and very, very near time frames. So they're more looking at what's happening today and early tomorrow. They're the models that we use for those really early time frames. And then we can branch out and look at what's happening further down the line using the global models. So once again, there's no one model that fits all. The idea is that we use a combination of them, and it's just understanding which model quirks have a greater accuracy or a lesser accuracy in that particular local area. Only way you get that knowledge is by watching what I do on the videos, and also by checking this out for yourselves. Hope you enjoy playing with the OCC weather models.